Hi everyone, welcome to all. In this video, we'll be discussing about machine learning lab. So let's start with the introduction. See, a machine learning is a core area of artificial intelligence that enables systems to automatically learn and improve from experience without being explicitly programmed. That is, teaching a computers to learn from data and make decisions on their own without being told exactly what to do. See, next is the increasing availability of a data and a computing power has made a machine learning a key tool in solving a complex problems across various domains such as healthcare, finance, e-commerce and robotics. Because we now have a lot of data and powerful computers, so machine learning is used to solve big problems in a different areas. See, for example, in healthcare, machine learning can look at medical records to help doctors detect the disease early. In finance, it helps in fraud detection. See, this lab will help students actually use machine learning on a real data, not just learn the theory. Yes, the lab helps you move from just understanding the idea of a machine learning to actually using it with the real tools and code. Then moving to the next. See, course objectives. In this, you will learn how to look at and understand data in a different ways, like one variable, two variable, or a many, and also how to simplify big data without losing important information. For example, you might use a bar chart to show sales by month, that is univariate, and a scatter plot to compare height versus weight, that is bivariate, and then PCA to reduce a 10 column data set to two main components, that is multivariate. Then next is, we'll learn different types of machine learning models and how to use them to solve the problems, like regression, that is predicting a house prices based on size. Then decision trees, that is nothing but helping decide whether to approve a loan. Yes, then clustering means grouping a customers based on behavior without labels. Then see, we'll understand how machine learning models learn and make decisions using probabilities, especially in situations where things change or are uncertain. So for example, in a stock market prediction model, things change every day. Yes, machine learning helps make the best guess even when outcomes are not guaranteed. And this is our first lab program. What this program does, see, it load a data set, that is California housing data. Then it plot histograms to see the distribution of each number based column, plot box plots to visually detect outliers, then use a mathematical method, that is IQR, to find and count those outliers, and then summarize the basic statistics of the data. And then these are the tools and libraries used. See, after installing Python and Jupyter, just go to command prompt and then click Jupyter Notebook. Then you will get this interface. Then go to new and select Python 3. And then we need to type our program from here. Yes, this is our first lab program. After typing this, just click on run. We need to install all these packages. After this, we'll get the output. Yes, see, I have already installed the packages. I'll just show how to install packages, like pip install pandas. After this, just click shift plus enter. It will install the package. Like this, we need to install all the packages. So now let's understand the program. See, this pandas are used for data manipulation and analysis. Then NumPy for numerical operations. Then Seaborn and Matplotlib These are used for plotting graphs. Okay. Then this skill and data set are used to load built-in California housing data set. See, in the first step, we are loading the California housing data set. Fetch underscore California housing loads the data set as a pandas data frame when as underscore data frame is equals to true. Yes. Then this housing underscore df contains all the housing data with the column names. In step 2, we are creating a histogram for numerical features. This line selects only the columns with a numeric data type, and it is useful because histograms and box plots are only meaningful for a numerical data. So the next is, this creates a new figure with a width of 15 inches and a height of 10 inches. This helps make the plots large and readable. It iterates overall numerical features in the dataset. Here, I is the index used for a subplot positioning and feature is the feature name. Then in the next line, this creates a grid of 3 rows and 3 columns for a subplots. Here I plus 1 sets the position of each plot inside that grid. For example, the first feature goes into the first subplot and second in the second subplot and so on. In the next line, it draws a histogram for the current feature. Yes, and KD is kernel density estimate. See, it adds a smooth curve over the histogram to visualize the probability density. Then bins is equals to 30. That splits data into 30 intervals or bars. Then color is equals to blue. Makes the histogram bars blue. In the next line, it sets the title of each subplot to show which features distribution you are looking at. Yes. So this method automatically adjusts subplot spacing so that titles and plots don't overlap. Then this method displays the complete set of box plot in one figure. Then in step 3, we are creating a box plots to find outliers. Yes. See, this creates a large figure with a 15 inches width and 10 inches height to hold all subplots. Then again it iterates overall the numerical features in the dataset. I is the index, then feature is the feature name. It divides the figure into 3 grid of subplots. I plus 1 determines the current subplot's position. Yes, each feature will be plotted in a separate subplot. It plots a horizontal box plotter using a seaborn for the current feature. See here, the feature is plotted on the x-axis and this makes the box orange. Then this line adds a title above each box plot indicating which feature is being visualized. This method automatically adjusts subplot layout to prevent overlapping text or plots. Then next in a fourth step, we are finding outliers using a IQR method. See, IQR is interquartile range which measures the spread of middle 50% of the data. Then it prints the message. Here it initializes an empty dictionary to store the number of outliers for each feature. And see, it loops through each numerical feature in the data set. Here we are calculating the first quartile and the third quartile for the current feature. So Q1 is the 25th percentile and Q3 is the 75th percentile. So next, see, this calculates the interquartile range. That is, it measures the spread of middle 50% of the data. Then in the next line, see, these are the cutoff boundaries. Any value below or above is considered as outlier. In the next line, it filters the dataset to include only the rows that have outlier values for the current feature. This stores the count of outliers in the outliers summary dictionary under the current feature's name. Then in the next line, it prints the number of outliers for each feature. And this brings a summary of data set. And this is our output. So thanks for watching. If you found this video helpful, don't forget to like, share and subscribe for more videos on this, and see you in the next video.